everyone. My name is Chu Wanjing. You can just call me Sora. This is our presentation for one of our statistical course, linear regression. And in this presentation, we're going to tell you about one of the model our group built. First, let me introduce my team members.
Hi, my name is Kao Pokyung. You just call me Daniel.
So in this presentation, first I'm going to introduce to you the outline of our PowerPoint. First, I'm going to tell you guys what model do we use and what data do we use and why did we choose to do this. And next, Daniel is going to take over and tell you guys about the detail and process of our model building. So after he's done with that, I'm going to take over again and tell you guys about the challenges and interface for this project that we built. So next, let's say this semester is going to end, and in the next semester, most professors need to pick their TA for the course they're teaching. So for example, let's say one of the professors in our statistical department, they wanted to pick a TA for their course. Usually the way that professors pick TA is maybe they will just look through the application of those students who apply for TAs, and the professors might take a look at for their GPAs, and maybe that's about it. But there's no guarantee that the TA the professor picked will be the best one among the candidates. So this is why we decided to build this model. So in this model, our team actually built a couple models for to help professors to pick their TAs. We built 4 models in total. The first one is logistic and then random forest, and we also built another 2 classification tree and the SVM model. So next, my teammate Daniel is going to take over and tell you guys about the model and process that we had during our project.
Hi, at first we go through what data do we have. So the data we have collected was obtained from the UC Irvine Machine Learning Repository. In the dataset, we have 151 observations with 5 predictors and 1 categorical response. The response will have 3 labels. Number 1 as a low performance, 2 is a medium performance, and 3 as a high performance. We don't have any missing values in our dataset. And in our predictors, we will have the first predictors as whether the TA is a native English speaker or not. The second predictor is also a categorical variable about the course instructor and about the course data and whether the semester is a summer or a regular fall and spring semester. And the fifth predictor is the class size. The first model we will cover is the logistic regression model, which is our simplest model. As we have known, logistic regression is very good in predicting 2 labels, classification. But in our case, since we have 3 classes to predict, that's why we will do some intermediate step. Specifically, in this case, when we will transform our data. So we have the first data set, which has label 1 and others. Others in this case means label 2 and 3. Accordingly, we'll have label 2 versus others, label 3 versus others. So we run 3 separate logistic regression, and we have the response is the probability that whether the label is 1 or others, and in other cases. And we pick the highest probability that the label will be 1 or 2 or 3, and we come up with our the highest chance that the TA will be in class 1 or 2 or 3. Okay. As a result of our model, we have a confusion table here. So in our logistic model, we have a 67% accuracy, but in this problem, accuracy is not the only metric that we are focusing on, because we also want to try to understand what this contribution matrix means. So we see here that the matrix is heavier in the lower half of the matrix, which means our model tends to under-evaluate the TA. For example, in this row, the real evaluation is number 3, but our model tends to have some errors predicting the TA as label 1. We'll see further in other model, and depends on the preference of the user. They may pick different model to be really conservative or not conservative. And in the second model, we have a random forest model. So because random forest can predict multi-classes, so we have 2 submodels within random forest. First is we just predict all 3 classes at the same time. And then secondly, we also use the same method as in logistic regression, which is one versus others regression. So we can see the accuracy of the 2 models are the same in our testing data, but the bias in the errors will be different. For example, in the 3 labels classification, we can see the model either we have very neutral bias. It can either over-evaluate or under-evaluate the TA. But in our one versus other random forest model, we tend to under-evaluate the TA, same like the logistic regression. And we also have the classification tree model. So we investigated 2 packages in R, which are R-part package and the tree package. So for the R-part package, we achieve lowest accuracy among all the model, and it tends to over-evaluate the TA performance. And the classification tree, we have a neutral evaluation. And we also investigate one model that has not been covered in class, which is support vector machine. And we try to experiment with 2 kernel functions, which is linear kernel and polynomial kernel. And we can see that support vector machine really outperform others classification models with the highest accuracy of 78% with a neutral evaluation of the TA. So to summarize our model's performance, we can see that the best performance is in support vector machine of polynomial kernel. And but in fact, if a simple model like logistic regression, we also can achieve good enough accuracy, and it's very conservative. So depends on the user's preference. Let's say the professor is very conservative. She just wants to pick a very good TA for her class, and she can just focus on the under-evaluation models here, which is maybe logistic regression or SVM with linear kernel. That's all for our model building. So next we'll talk about some challenges that we face in our data set, which we covered by Sora.
Okay, so after Daniel has walked us through the model building process, I'm going to talk about some challenges that we have during our project. So the first challenge that we have is that the data set we have is quite small. We only have 151 observations, which means the model that we build, the prediction ability might not be that good since we don't have too many data. And the second challenge that we have is that, as we mentioned before, when Daniel talked about the data we have a couple category variables, but we failed to identify the meaning of these categoricals because the categorical variables has numbers and it's ranged from 1 to 26. But we failed to identify the meaning behind every number. So, for example, number 10, we don't know what number 10 stands for. We only know that it stands for one of the major or one of the course. And the third challenge that we have is that for some categorical variables, there's unique levels. So here, this is a table for all the levels categoricals occur in our data set. For example, if you take a look at number 4, the second row is going to tell you how many times the number 4, this category, shows up in our data. So here, number 4 only shows up once. So this is going to cause a problem is that, let's say we have our model and the user wanted to use our model to evaluate their TA. And in that categorical user input number, let's say number 4. And then, but our model is going to tell the user that because in our test data, in our training data, number 4 never occurred. So the model is going to tell the user that they don't know how to handle this new number. So this is going to be another problem for our project. So next, this is the interface that our team was going to build, but due to the limited time, we didn't build that interface. But here you can see that this is our whole idea of how we were going to build the interface. So first, we're going to upload our model to a website, and after that, we will provide a couple variables that user is going to input. So we have first whether the TA is a native speaker, and second one, course instructors, and another one, course, and whether this course is provided in summer or provided in regular semesters. And then the last one is the class size. So after the user input all these variables, our model is going to return a number back to the users. Well, also the user can choose which models they wanted to use. Like Daniel said before, maybe if the professor is conservative, then he can choose a model that tends to under-evaluate the TA. If the professor is more open to new students, new TAs, they can choose a model that tends to neutral evaluate the TA or overestimate the TA's ability. So this is the whole presentation and our project. We hope you guys understand what we were doing, and I hope you guys find our project to be useful in the future. Thank you.